Hello everybody.
Hi Chris.
Hello. We're on the internet. Hello internet.
Hi internet.
Hello everybody. Hello. We're beginning. Hooray. Good. Thank you for coming everybody. Copenhagen Ruby meetup again. It's going to be a little tricky this time. We're doing some fancy technology, so it's going to go wrong probably at some point. So, would you like to wave at the internet? We can do that this time. Wave, wave, wave. You're real people.
It's true.
And now people get to see me again. Hooray. So, Copenhagen Ruby Brigade, that's where we're at. These are everybody's favorite slides. Let's see if I can navigate through these. Oh, that's the last one. You're here. You know that. What's happening in 2021? I'm meeting every month. Not quite held up to that, but we're back on track. Every second Wednesday. It's early this time because the first day of the month was Wednesday. Who could have foreseen that? So, early again. Every even month we're at Karnov. Odd months we're somewhere else, and that's today. So, we're being hosted by Soundtracktor. So Nikolai's been doing that for us. Thank you very much, our gracious hosts. And if you would like to host, please get in contact. We would love to see more venues, more places. Please do a talk. We don't have enough speakers. It's always hard to find speakers. We're a small community. Nobody thinks they have anything interesting to talk about. Everybody does. So you're all wrong. If you don't think that's the case, come do a talk about why that's not the case. So some examples of talks. Talk about anything. It's a nice soft audience. We won't boo you off stage. But the internet might be tough. We also have a code of conduct. Be nice to each other. Be excellent. We want to have a good time. So inclusive. If there are issues, contact myself or one of the other organizers and we'll try to sort those. And as always, please give feedback. We want to make this better. And we're trying out some fancy tech, so that's our first attempt to make things better because not everybody can always make it. So let's try get our first speaker on the go. There he is.
Oh, hi.
Do you want to come introduce yourself? We're going to try switch over gracefully now.
As gracefully as we can manage.
Gracefully. So you get to go here, you plug that one in, you get your face cam.
Hi guys.
Hi.
And then we just gotta wait for the TV to stop saying that. Would you like to try again?
Sure. Can everybody see through this lamp, or is it a bit in the way?
It's a bit in the way and gives off a very strong reflection.
That's dope. That's great.
You put all the content on the outside of your slides?
yeah. I'll make it go to the edges.
Slides,
Well, it seems like we've got
slides.
Hey, that seemed like it did something. It helps to plug stuff all the way in. I don't know if you guys have experienced that in your lives, but oh, well, that's my Slack. Hang on a second. Don't read that. It's private.
That's
and
okay. It's
and
not
very
on the internet
interesting. And it didn't remember that. I want to see what I'm doing. And the slideshow, please. Okay. Maybe we can try and do something about the lamp really quickly. Could just tie a knot.
Should we get an electrician?
Is it a union thing? Do we have to do that?
I don't know.
Okay.
Maybe with a spoon or something?
Yeah. Okay, so for the first part of my talk, I'm gonna tie a small knot in a bit of lamp cord, and
This couldn't go wrong.
no.
Is it high enough?
Yeah.
How many rails developers do you need?
This many.
I'm gonna let it go now. Okay, you got it.
extra points if you do this successfully first time.
Looks legit. All right.
Hey.
Alright. So any questions? That was actually my talk. So if there's any questions. No. What I'm here to talk about are solar graph diagnostics and building your first and second plugins. And briefly, just about myself, because I haven't seen most of you, well, I guess last month, but like in a year before that. My name is Cameron. I'm a developer at a startup here in town called Deep Diver. Jens is the other half of said development group, so we're hiring. And if you like working on projects like this and you think this stuff is interesting, I worked on this in part on like at work, and it was solving some work problems, so that's what kind of spurred on this talk. So talk to us after this. So it's going to be a talk in two parts. The first part, we're just going to go over some basics of what Solar Graph is, the built-in stuff, and some development setup. And then the second part is the cooler part and the more interesting part, and the reason why I'm doing this talk in the first place. And it's basically, we'll build a simple reporter, and then I'm going to show you guys something that I've been working on for the last few weeks, which is much less simple but way more practical. So let's begin. Who here is using Solar Graph at work? Damn, for real? Okay. Who here knows what a language server is? Okay, so a language server is a protocol developed by Microsoft for VS Code. It's editor agnostic, so you can use it with Vim, Emacs, NeoVim, VS Code, Sublime, basically any editor that supports plugins. You can write a plugin to talk to a language server over standard I/O or sockets or TCP/IP or whatever. And they're language specific. So the Ruby one's written in Ruby, the Haskell one's written in Haskell, the TypeScript one is written in TypeScript, and it provides stuff like formatting and go-to for definitions and classes and auto-completion and diagnostics, and the protocol is enormous. And it's actually pretty clever because you get to write a plugin for your language that runs on every editor. So it's no longer like Sublime's Ruby versus Vim's Ruby versus Emacs's Ruby, but it's just the language server handles all that. So Solar Graph is the Ruby one, the best, the big Ruby one at least, and it's open source. And the guy gets like 700 crowns a month and it's absurd. Like, read through the code base, it's really well built. Except he doesn't put parentheses in his definitions for the parameters, but that's, you know, spaces or tabs. But consider supporting it if you have some extra money kicking around, because it's really, really cool work. And so diagnostic is just real-time feedback for the file that you're working on. That's it. So let's see what that looks like. So you can get, it's this little bit at the bottom here. So it says there's no test file found. Or you can get like information, so Rubocop can tell you like, oh, so prefer blah, blah, blah. So there's your Rubocop diagnostic. You can get warnings on stuff, and you can get errors if your code is wrong. And this is all provided by a diagnostic plugin. So the Solar Graph API basically lets you write plugins, which is what I'm going to talk about, a little bit foreshadowing there. Built in with Solar Graph, you get Rubocop. You get something called require not found, which tries to find the packages you're requiring, and it's usually wrong because it usually yells at you, but it's there. And then type check, so if you're using yard docs for your method signatures, it'll tell you that you forgot to do stuff. And this is all happening in real time, so you just get the feedback in your editor. So let's talk about building a diagnostic reporter. So first you have to set up the language server with your editor. There's packages for Vim, there's packages for Emacs, there's packages for VS Code, but that one's on you. Install Solargraph, make sure you have it with gem install or in your bundle or wherever, it doesn't really matter. What I found really useful and what I'll show you guys in a few minutes is you can run Solargraph in the foreground in a terminal window over a socket. And then you can tell your editor to use Netcat to talk to that language server. So you can interact with it in the same way that you can interact with your Rails server and put in like a binding.pry or whatever and then see where you are in execution. You can interact with your language server as long as it's communicating via Netcat, which is pretty cool. This is the base class in the Solargraph code base that you are implementing for a diagnostic. So basically, it's real simple, and all you're doing is you re-implement diagnose. That's it. So as long as you're implementing a diagnose method in your inherited class, that's the only thing you have to do. And you get a source and you get an API map, and the source param is specific for the current file that you're looking at. So that's a nice object that contains the source code as a string and the source code as an array split at new lines, and a parsed abstract syntax tree of the file that you're looking at, as well as its absolute file path and a ton of other stuff. And then the second parameter, the API map, is that but for every file in the workspace. So you would run it, you would launch it in like your project's root, and it crunches your whole workspace and then has it in memory, and it lets you interact with every file if you choose to. So let's get into the fun part. Nope. There we go. Okay. Remembering what I'm doing. So this is a basic little setup that I built last night. On the left there is our language server running in the foreground, so you can see that it's running on a socket. And on the left here, we have like the example off of the Solargraph website. So this is the simplest possible reporter that you could have. You are requiring Solargraph, and then you implement a class that inherits from Solargraph diagnostic base, which is what I showed you a few slides ago. And then you just implement the diagnose method. And what this reporter is doing is it's going to yell at you if you forget to put frozen string literal true or false, whatever, at the top of your file. So you can see in the guard clause here, if it's empty, don't do anything. And if it starts with frozen string literal, don't do anything, because that's what it's checking for. And all this method needs to return is an array of hashes. And the hashes contain the range, so the starting line, the starting column, the ending line, and the ending column, because it can put that in your editor and tell you exactly this part is shit. Then you can do a severity. That's what I show you with info or hints or warnings or errors. So you can sort of, green, blue, yellow, red, however you want to provide it. The source, so this is coming from frozen string. And then the message that you want to provide to the user that here's what's going to show up for them. And then you just use the API to register your diagnostic. And that's all there is to it. So I think I already have it running. So if this all works, it's like that. So you get rid of it, and then now it's not yelling at you anymore because it's there. Your editor, mine is set up to send it out every time you update the buffer. I think you can tell it to do it when you press a button, or just every time you update the buffer is a pretty good time, because that's when you change stuff. And let me see if I remember what I was going to do next. Yeah, I do remember what I was going to do next. So you add frozen string. This is the Solargraph config, so this just sits in your project root. You add the reporter, you tell it to do the plugin, and it does all the requiring and everything for you. So this is all of the config that you need to set up your first diagnostic plugin. And it's literally that easy. Like, you have the whole source code of the file, you can run it against whatever you want, and you can return whatever messages you want using the array of hashes, and you don't have to worry about writing the Vim plugin, the Sublime plugin, the Emacs plugin. All of that's taken care of for you. You're just worrying about feedback on the language. So let's get into the reason why I actually called you all here tonight, which is that I've been writing thanks. I've been writing a more complicated diagnostic plugin, because a few weeks ago Jens and I were talking about how it could be frustrating to not see unit test coverage in specific files. Like, if you're using something like SimpleCov, your system specs, if they hit a file, that counts as touching it. So you can't see, does my unit test touch these lines? And I figured that this was actually a pretty decent application for a diagnostic plugin. There's another gem that Ollie recommended called SingleCov, which attempts to do something like this, but it requires a bit of upfront installation, which isn't a big deal. You have to put a little statement at the top of every spec file that says, there's these many uncovered lines, or it's totally covered, and then it'll yell at you after running your test suite if that has changed, which is totally a cool tool. But we wanted some more real-time feedback on if stuff was covered or not. So I went through the SingleCov source code, I went through the SimpleCov source code, and I started going through how to actually build this, and I had an idea for a talk, and that's why we're all here. So I'll just turn that on, kill you, turn you back on. So it's got to reload the config. Oh good, it's still working. That's awesome. You never know when you're giving a talk if it's just going to be like, oh, no, now, right now. So, no. The first place to start, you'll tell it to turn on so it connects. The first place I want to start is with test coverage. So this diagnostic will look and see if there's a test file for your model, your component, whatever you're doing. It'll see if there's a corresponding unit test file, and if there isn't, it'll give you a friendly little warning at the bottom and tell you where it looked and that it didn't find one. It's not always this obnoxious highlighted green. I just thought it would be cool. It would be a little, I like it more subtle, but for the sake of a talk, subtlety is often lost at a distance. So that's the first place I started. The next is I wanted to see actual line coverage. So I figured it'd be cool if it told you if a line was covered or not. And then because the coverage module that ships with Ruby also gives you branch coverage, I figured why the hell not tell people if their branches aren't covered either. And then for the last little bit, I thought it would be really cool to show you. Let's see if it did that. No? Hang on. Oh, because I didn't write the test yet. Yeah, that's what I was going to show you guys. Always, you rehearse for these things, but anyways. So, go, then go to our unit test, and we see initials isn't covered right now. So, turn that on, save our buffer. Hey, look at that. It is covered, but if you look on the left, it failed. And up at the top here, it tells you that the test is currently failing, because we have that information, and why not show it to you? Because you want to see if you change something and your test is failing. So we can come here and say, oh, actually, and you see our spec runs on the left instantly, and now, hey, look, it's not yelling at you anymore, which is all I've ever wanted in life. So we'll come down to the admin and see it's telling us that our then branch isn't covered and our else branch isn't covered. And, you know, we turn that back on. And now, hey, look, now it's just the then branch. That's really fast. Wow, how cool, Cameron. No, don't double comment it. You know, tools are only as smart as the programmer that uses them. And now we got full coverage and nothing's yelling at you anymore. And it was all run in a background process. You wouldn't normally have it in the foreground, of course. So it was all run in a background process in memory. And so I'm going to show you how that whole plugin works because I think it's really cool and I learned a bunch of cool stuff. First question.
Do you have a separate file watcher thing running, or is that stored
No.
as well?
That is how the language server talks to your editor. So when the buffer is updated, the editor sends it to the language server processes it, and sends you a response.
And the language server triggers the
Yep.
spec run thing.
Yeah. So that's the plugin that I wrote.
Cool.
That's the plugin I wrote. Is that. And working, this is obviously like a little dummy application that I built, but even on our production application where I use it, you still get lightning fast RSpec coverage because of some optimizations I did, which we're gonna get into because that's the fun part. But let's start at the beginning, which is the diagnose method. That's all. That's the entry point for everything. So it's the same sort of, you get, if it's empty, just give me an empty array, or there's some files that you don't want to have a unit test for, like a controller or a concern, or a test file, because you write a unit test for a test, so we'll just, if it's an excluded file, just return an empty array.
You don't test your tests?
Oh my god, do you?
I thought you were supposed to.
This is what's holding it. You know what? We got to talk. And then the next guard clause is, again, it's returning our array of a hash, which is if it can't find the test file, just, you know, we have our hash right here where you take the source, and the source is used so that you can get how long the line is, because you want it to highlight the whole line. Otherwise, you could have it highlight less or more, but I wanted to just make that whole line red. And yeah, so it just tells you the source is test coverage, the severity is just a hint, and no test file found at where that test file is. And then since it's run out of your project root, dir pwd is your project root. So that's a really nice way that you can just see where you are, because I just wanted a relative path, not, you know, users, Cameron, code, blah, blah, blah. The cool part, I think, is running the test. So one of the problems with doing coverage is that you need to test it in isolation. Otherwise, you contaminate the file under test because you've loaded and used parts of it. So I needed a way to run the file under test in a controlled environment, but get the results back from that. And the original way that I went about this was just using the little backticks to send it out to the shell, and then having it output as a JSON, and then parse the JSON and it worked and could be improved on. So I found this nice little fork process in the Rails source code that's used to test some shit. So what it's doing is opening an I/O pipe, forking the process here. There's some boilerplate involved, so you've got to close the read, yield to the block, which is the test that I want to run. Marshall dump the results so that you get the binary of the Ruby object that you want. Exit, then wait for the child process, and then take that binary and turn it back into the Ruby object that I wanted. So that's a nice little clean way of making sure that the test is run in isolation, but the block just returns a hash and you don't have to actually worry about any sort of JSON parsing. So that's just this block right here. So this is using the built-in Ruby coverage library. So we just start coverage. Test runner is a tiny wrapper because I put in experimental mini test support, even though I don't use it and I don't know anybody who does, but they have basically the same API as our specs, so why not? You pass it a file and you use run. There's minor differences, like mini test returns a Boolean if it passes, and our spec returns 1 or 0. So to get to see if it passes, it's just yeah. Anyways, object-oriented programming is cool. Coverage.result stops recording because we've already run our test. It clears out its whole coverage memory, and coverage results is a hash where the absolute file paths are the key, and then the value is the line coverage and the branch coverage. So we just use the source location file name, and that returns the coverage for the file that you wanted to test, so your model file or whatever. And then for fun, we pass in the test status to see if it passed or not, because we want to know if it passed or not. Back to our diagnostic method, we take the results of that and we crunch messages from that. Messages are just line warnings, branch warnings, and whether or not it passed. And all of these basically turn into arrays of hashes if there are warnings for lines, branches, or if the test passed or not. Branches are kind of a pain in the butt because it returns like a hash with hash keys with hash values, or it's convoluted, and SimpleCov came up with a really great way of just turning that into an object. So I just borrowed their branch object, and then you get nice little like branch dot passed or covered or whatever. Like it's just way easier to deal with. Flatten it, compact it, get rid of anything that's nil, and that's what's returned. So that's the whole process, start to finish. Is it comes in, it has those guard clauses, it runs your test in a forked process, brings the results back into your parent process, makes any diagnostic errors or hints that you might have, and returns that. And then if the child fails, then just return an empty array, because whatever, you'll try again in a minute. Now I can hear all of you asking, but what about having to require Rails helper, and what about having to require your testing framework every time you run the test, because that would be super expensive and take on average 3 to 9 seconds. Great question, you guys, because nope, one file too far. This is the top level of the gem, and you can require that stuff in the parent process and it's still in your child process without issue. So we require the testing framework and preload Rails. So of course I had to build a config system. Preloading Rails was kind of cool because you have to see if there's a Rails helper, and you have to check. I don't know that you have to check if Rails is already defined, but I figured if it is, you don't need to. I don't know why it would be, but it felt like a good idea. This is borrowed from the Rubocop diagnostic. So basically adding to your global load path the test path, because Rails helper will often require spec helper, which if you're in the spec directory is no big deal, but if that's not in your load path, it'll blow up. So you put the spec directory in your load path so it finds your spec helper. So you don't have to change any of your current test setup. Then requires the Rails helper, and since a lot of people probably have SimpleCov or SingleCov already in their Rails helper, coverage just started. And you can just stop that in its tracks because we don't care about that right now. So if it's running, stop it and clear it. And then just, return true, no big deal. And then similar with require the testing framework, just if you said RSpec, bring in RSpec. If you said mini test, require mini test. And if you said a third thing, why? No, I just didn't want to support it. That's all. I built this like last week. Is also, I should say that I built this last week. And I think the last thing I'll talk about is how to actually configure it and how to actually like load your workspace config. So I wrote this little config system that takes your, this is the Solargraph YAML file that would just sit in your project's root directory. And I wanted to be able to just configure the plugin there because that's where you would do it. So I gave myself a little key. And so you can tell it to preload Rails, yes or no, RSpec or Minitest. If you want to turn off one of the diagnostics, you can override this and say like no line coverage, no branch coverage. If one of them you don't care about, you can turn them off. And then the exclude paths was what I was talking about earlier, where if there's a directory in your application that you don't have corresponding unit tests for, you can say if that's in the absolute path, get rid of it. I haven't come up with a smart way of, it's just seeing, does the string contain this string? And if it does, it throws it out. Yes, that could be improved again. I did this like last week, so I appreciate your understanding. And yeah, you have access to that through Solargraph's API, so that's just a new workspace config, and then you point it at the working directory that you have. Raw data, and then fetch your key, or give yourself a little empty array because you've got a bunch of defaults, which is what I showed you in that YAML file, but at the top I figured it'd be cool. You just have defaults, so if a key hasn't been provided in the YAML, it'll use this, but if you provide the key, it'll just use what you provided instead, which made sense to me. And then the config module is then just basically a series of predicate methods that you can just say like config.line coverage. And if it's true, they want line coverage. Or config.exclude paths, preload Rails, blah, blah, blah. And then in all of your coverage warnings, you can just say like, don't do this unless they want, which I hear is what is all the rage these days. And that's more or less it. It's really awesome. It's really, really fast. I think it's super cool because, yeah, it's all just loaded in memory, and so it just returns everything damn near instantaneously as you're making changes in a file. And it's a really easy way at a glance to see if your unit tests are good or not, which is sometimes the case. So you can start using this now, actually, because it's on Ruby Gems and it's also on our company's GitHub. So you can see the source code. I'll put it in the chat afterwards, because I'm super excited about this. And pull requests are like super welcome if you find stuff that you think you could do better. Or if, again, I wrote this last week, so like I'm not saying it's perfect. I'm just saying it works, and we've been using it in production on our applications, and it's great. It works really fast. So it's on Ruby Gems, so you can just add it to your gem file, or if you want to run Solargraph outside of your bundle, just gem install it. You know how to. You should know how to install gems. That's not what this talk is about. So basically, LSP plugins are awesome because this works on VS Code and Vim and Emacs and Sublime and provides the same diagnostic feedback to your coworkers regardless of what their preferred editor is. So you no longer have to worry about like, oh, well, you know, I have a Vim plugin that does. I mean, that's, again, a different talk. It's a really good API using Solargraph. So read through their source code. It's really well tested. I figured out how to do most of this stuff just by reading through Solargraph and SimpleCov and SingleCov and trial and error. You know how developing stuff is. And if you can't find the right tool, build it, because you'll learn a lot. Because it's not like I have to work with forking processes at my job. Um, but now I know a little bit more about forking processes and I/O pipes and blah blah blah. And if you guys have any questions, I don't know how long that was, but hopefully long enough. That's it. You have questions. I'll answer questions. Wow, chatty punch. Okay. Yeah, what's up?
The preloading and then forking, I had never thought of that. I think that's genius. I've
Sick.
spent I don't know how many hours like worrying about my tests take 1 second too long to load.
Yeah.
Crazy. Why? Like why is that itself not a gem? If you can like watch for file changes and then fork in the back.
It is. It's called Spring.
I was about to say. Isn't that's
It is.
yeah, and if
Is
what
Spring? Are you not supposed to use?
Nobody likes spring anymore.
Yeah, that's what I heard.
Not anymore, but I use Guard with RSpec and Spring, and it is blazing fast.
Yeah.
yeah.
Very good. Yeah. This
But
one,
is that actually what Spring does?
Yeah.
Alright.
Spring is nice if you remember it's running because for the fork process, all your environment
I just
variables are
remember that it
cached.
broke all the time, and I would get tired of restarting.
It's not Spring that breaks, it's more that if you're changing any stuff that happens before the fork and it's not working for some reason, you can't remember why, it's because Spring has cached everything for you.
Yeah.
And then you forget it's running because it's seamless and transparent, and that is kind of opaque, and people don't know that that's happening necessarily.
Or you just have to spring stop to
Yeah.
start again, right?
Yeah, but you have to remember that every like 3
Yes.
months when it
When
breaks.
you're wondering why I made changes, but the changes aren't being reflected in the it's because it was cached.
Usually that's when you realize that you have to spring start, like it should work.
Yeah.
Computer is not fair right now. But
No.
yeah.
No. So that's why I put the preload behind a flag, because maybe it breaks stuff. I don't know. This again, wrote it last week, and it does save you a lot of time by preloading your Rails helper. But of course, if you change your Rails helper, it's already been loaded. So your RSpec or Minitest isn't going to pick that up. That said, I don't know how often you guys change your Rails helper. Occasionally, yeah, but probably not daily. Oh, I don't. I'll put it out. I don't change it that much.
It's a trade-off, right? Like if you change
Yes.
your Rails helper, or if you bump into like Spring being annoying like once every 10 days,
Yeah.
and that makes you say once again 30 times an hour,
Yeah.
it's a good deal.
Yeah, that's right. Any other questions? Cool. Go give me a GitHub star,
Yeah.
which is the real reason I'm here.
Thank you very much, Cameron. So we're going to go on a break here to eat pizza, set up next speaker, talk a bit. So, Mr. Stream, you're going on pause for now, and come back later.
We have minutes. Now we have good minutes. I don't think we. Is that the screen? Is that how it looks
We're
like?
not quite ready yet.
No. But I mean, if I stand back here, am I in screen?
Yes.
If I stand over here, I'm not in screen.
Yeah,
Poke
you're too
that thing.
tall.
It is like nostril cam. I should go back.
So one of these things
Yeah.
plugged in.
This is an Armani tie. I'm really happy with it. Okay.
Did you try jiggly poke your wires a little? You're not
Poke my wires? Yeah. I am.
I mean, it was working before. I think you just
You touched something.
Okay, I'll do it again then. Okay.
Do the opposite of what you did to make it break.
Cool. We'll do that. I'm sorry. We were there, but we're not.
That's what it tastes like. Yeah. I didn't I'm here to watch it.
So we're not streaming.
No, well, we're streaming you.
We're streaming me.
Yep.
Okay.
Audio.
Great.
Just trying to get.
So cables. Shall you just flip it? If
Try
it's
that.
about being broken inside.
Let's go mute so we don't reveal our diagnostic secrets.